All right, let's talk about something that sounds like it's straight out of science fiction: quantum computers. We're going to dive in and try to demystify what they are, what they can actually do, and, why they're suddenly such a huge deal.
So, you see headlines like these all the time, right? Quantum supremacy, bits, qubits. And if your first thought is, what on earth are they even talking about? Well, you are definitely not alone. The news around quantum computing can be super confusing, and honestly, a lot of it is just plain wrong. But don't worry, we're going to cut through all that noise together.
Okay, first things first. Let's get the number one biggest misconception out of the way right now. Quantum computers are not just bigger, faster versions of the laptop or phone you're using. There's something else entirely. And understanding that difference, well, that's the key to the whole shebang.
To really wrap our heads around this, we need a really good analogy. So forget about building a faster car. We're talking about inventing a whole new way to travel. Think about our ability to solve problems like we're exploring a giant map. For centuries, with just pencil and paper, it was like we were walking. It was slow going, and most of the map was totally out of reach. Then, early computers came along. They were like getting horses. Suddenly, we could go way farther, way faster, exploring all these new territories. And today's computers, they're like supercars on a massive highway system we built, letting us solve problems that would have been unthinkable just a generation ago. So if our modern computers are cars blazing down these roads we've built, what are quantum computers? They're boats. And that right there is the most important idea. They aren't made for the roads we've already paved.
This quote just nails it. A boat isn't better than a car, right? You wouldn't take a boat to the grocery store. It's built for a completely different kind of terrain: water. Quantum computers are built to navigate these brand new mathematical oceans, to solve problems our cars can't even get close to.
Okay, so we've got our boat. But how does this thing actually, work? What's the engine? To get that, we have to look at its most fundamental part. Every single computer you've ever used, your phone, your laptop, everything, runs on things called bits. And a bit is incredibly simple. Just think of a light switch. It's either on or it's off, a 1 or a 0. That's it. Everything you see on your screen is just built from billions of these simple little switches. Now, a quantum computer runs on something called a qubit. And if a bit is a light switch, a qubit is, well, it's more like a wave in a pond. It's not just on or off. It can be a 0, a 1, or this whole range of possibilities in between, all at the exact same time. It's a weird, fuzzy state of maybe, and it's called superposition. So let's just put them side by side for a second. A classical bit is binary, a light switch, holding just one value at a time. A qubit, on the other hand, exists as a spectrum of probabilities, a wave, holding many possibilities all at once. That one difference, that is where all the incredible power comes from. So how do you get a real answer out of a bunch of fuzzy waves? This is where it gets kind of mind-bending. Thanks to superposition, the computer can explore a huge number of possibilities at once. Then, through something called interference, those waves of probability can actually interact. Just like waves in a pond, they can add up and get stronger, or they can cancel each other out. The whole point of a quantum algorithm is to make the waves for the right answer get bigger and bigger, while all the wrong answers just fizzle out into nothing. And then there's entanglement, which links qubits in this bizarre way that Einstein called spooky action at a distance.
Okay, so we have our quantum boat, and it's powered by these really strange and powerful qubits. The big question now is, where can we actually go with it? What's in these new oceans we can finally explore?
Right. What's actually in the water? What are the kinds of problems out there that have been completely impossible for us to solve, but now might be within reach? For now, there are two huge new worlds that everyone is focused on. First is the ability to simulate nature in a way we've never been able to before. And second is the one that gets a lot of attention: breaking modern encryption. Let's start with nature. Here's the thing. The world down at the molecular level is fundamentally quantum. It runs on these same weird rules of probability and superposition. Our normal computers are, well, they're really bad at faking that. A quantum computer doesn't have to fake it. It speaks the same language. This could be a game changer for designing new medicines, creating brand new materials, or even figuring out better batteries. And now for the one that has governments and security agencies on edge: encryption. The security that protects your bank account, your private messages, basically the entire internet is built on math problems that are incredibly hard for normal computers to solve. How hard? We're talking billions of years for a classical computer to crack it.
A powerful enough quantum computer, though, it could potentially do it in hours or days. I mean, just let that sink in. Billions of years versus a few hours. The scale of that leap is just staggering.
Okay, yeah, that's a pretty scary thought. So let's explore that a little bit more. Do we need to panic just yet?
Which leads us to the most obvious and urgent question. Is our online data, our banking, is everything vulnerable right now?
The short answer is no. Not even close. See, to crack that kind of encryption, experts estimate you'd need a stable quantum computer with 1 million qubits, maybe more. And today, the record is 433. So as you can see, there is a pretty massive gap between where we are today and where we would need to be for that to be a real threat.
But, and this is a really big but, while that gap is huge, there's nothing in the laws of physics that says it's impossible. And there's one thing we've learned over and over again in science. If the physics says something is allowed, then eventually the engineers will find a way to build it. It's probably a matter of when, not if.
So where does that leave us? What does this all mean for the journey ahead?
I think this quote from a researcher at IBM just captures it perfectly. Everything we've talked about, simulating molecules, breaking codes, we are just skimming the surface. We're going to discover things we can do with these machines that we haven't even thought of yet. It really is like we're looking out at a bottomless ocean.
And that's really where we'll leave it today. We started out with a bunch of confusing headlines and ended up with a whole new way of seeing computation. It's not about a faster car. It's about a boat setting sail on a new ocean. And that leaves us with one final incredible question to think about. In a bottomless ocean of new possibilities, what are we going to discover?